Now this is topic 3.4, integration by parts, question 2c. So we've got the integral of r squared cos of r. Okay, so we should be getting used to the how to pick our u's here and how to pick our dv's. So just remembering, whatever u we pick, ideally we'd love to be able to keep differentiating it till it turns down to 0. So that would be the r squared there, because cos, if we differentiate it over and over, we'll just keep bouncing between cosine and sine. So we'll choose our dv to be cos of r. So let's differentiate. du dr is equal to 2r, so du is equal to 2r dr. The integral of dv is equal to the integral of cos r, which is sine r. So that means v is our sine r. So we got our four important pieces. We got our u, we got our du, we got our dv, and we got our v. So let's apply our formula. The integral of u dv, that's the thing they asked us to do, is uv minus the integral of v du. So u dv, as I said, is what they gave us to do, r squared cos of r. So the integral of that is equal to u times v, which is r squared times v, which is sine of r, minus the integral of v du, which is sine of r by 2r. And I'll just rewrite that in the opposite order, 2r sine of r. And I've got my dr. Okay, so that's all dandy, except for the fact that I know I cannot integrate this yet, because I've got two different functions multiplying each other, two expressions multiplying each other. So I have to do another integration by parts here. So I'll let my u equals 2r, and my dv equals sine of r. That way, du dr is equal to 2, so du is equal to 2 dr. The integral of dv is the integral of sine, which is minus cos of r. So that means v is minus cos of r. And we have our four important parts, our u, our du, our dv, and our v. So we're going for our integral here. We've got our r squared sine of r minus the integral of what's in our blue box there. But to integrate that, we have to do our integration by parts. So our u times v, so uv, 2r by minus cos r, so it's minus 2r cos r, minus the integral of v du. v du is minus cos r by 2 dr. So I'll just rewrite it in this order, minus 2 times cos of r dr. Okay, so I'll redo this a little bit. I've got r squared sine of r. Oopsie daisy, sorry, my pen is trying to catch up with me. Sine of r. Now I'll do my minus, which is a plus, 2r cos of r. And my minus again, which is a plus the integral of minus 2 cos of r dr. Now I'll bring my my minus 2 outside, so I have r squared sine of r plus 2r cos of r minus 2 times, oh my goodness, minus 2 times the integral of cos of r dr. So that's r squared sine of r plus 2r cos of r minus 2 times, now the integral of cos of r, integral of cos is sine of r. Now at the very end, so we just do plus c.